Hello everyone, this is Dr. E, and for today we're going to be working on conditional statements in geometry. Just like what I've been telling you in geometry, it's not enough that we are memorizing the formulas that will help us find the measurements of our geometric figures. Sometimes you also need to be able to articulate some of the processes mathematically, and this is what we're going to be working on in our lesson for today. And we're going to start with a very important type of statement in mathematics called the conditional statement. And by definition, a conditional statement is a statement that is written or that can be written in if-then form. So these are type of statements that we often see in most theorems in geometry, and to be able to understand how we formulate statements according to this form will help us understand geometry better. So, when a statement is in if-then form, the phrase that follows if is what we call as the hypothesis, and the phrase that follows then is called the conclusion. So we have two parts of the if-then form statements or the conditional statements. So we need to be able to identify the hypothesis and the conclusion in a particular statement similar to this one. So this is an example of an if-then form, which is a technical or in technicality, or if we want to be technical in mathematics, to call this statement as the conditional statement. So in this sentence, if a figure is a pentagon, then it has 5 sides. So this is an example of a conditional statement because we know that we have a hypothesis, which is a figure is a pentagon, and we also have a conclusion, which is it has 5 sides. So this is one example of a conditional statement, which is pretty straightforward and pretty easy to understand. All we need to do is to be able to identify the hypothesis and the conclusion. So if you can think of an example of a conditional statement, comment it down below and I'll give you another one. Let's say if it's cloudy outside, then it could rain. So we have the hypothesis, which is cloudy outside, and the conclusion is that it could possibly rain. So that is how we understand or formulate a conditional statement. So let's have another one, which is using shortcuts. And I know most students love to use shortcuts in mathematics. And it's also true when we are working with conditional statements because we are using or we can use symbols and notation to be able to write a conditional statements in symbolic form. So how are we going to produce that? So let's say our hypothesis that we're going to be working on is that an animal is a turtle, forgive me, turtle. There. So that is going to be our hypothesis. An animal is a turtle. Maybe I should just use a different animal instead. But here's our conclusion. The animal is a reptile. So this is going to be our hypothesis and conclusion. And to be able to form an if-then statement or if-then statement using a shortcut or a notation, we will assign variables just like how we use variables in algebra. But this time, the letter is not equal to an expression or algebraic expression or a numerical value, but in words, some phrases. So this is an animal is a turtle will be our P, and the animal is a reptile will be our Q or our conclusion. And to be able to write this in symbol form, we need to first write this in verbal form. So in verbal form, our conditional statement is now if an animal is a turtle, then the animal is a reptile. So now that we have this conditional statement and we know that P is our hypothesis and Q is our conclusion, we can simply write this as P then Q. And we can understand in the language of mathematics that we are referring that this tiny little symbol right here or Shortcut is actually has its meaning. And the meaning of P then Q in this particular statement is that if an animal is a turtle, then the animal is a reptile. I really cannot say turtle. Right. So hope I should have just changed the reptile into a cobra. Would have been easier. Anyhow, another way of writing this down is P implies Q, and in symbol form, we can use an arrow pointing to Q or to the conclusion to have a conditional statement of this form. So these three forms of if-then statements is understood to be an if-then statement using variables and symbols. So let's try this out and let's identify the P and the Q in this statement. So in this statement, if a number is even, then the number is not odd. So in this case, we need to identify our P and our Q, and to be able to write it down, let's write our P, which is our hypothesis. And our hypothesis in this form would be a number is even. So this is our P or our hypothesis. And for our Q, which is our conclusion, we can write Q here as the number is not odd. So this is how we identify P and Q using this statement. And once we are able to identify our hypothesis and our conclusion using symbol form, we'll be able to write this out in different notation because we now have P and Q. So to be able to rewrite our statement in mathematical notation, we can write it out as P then Q. We can also write it as P implies Q, or we can also use symbols like so. And all three of them are all considered conditional statements that reads us if a number is even, then the number is not odd. So that's how we identify our P and Q and how we write it in this notation. And if we are going to have another example on how we'll be able to use notations to understand the language of mathematics in symbolic form, let's say we have P as a figure is a square and Q, the figure is not a triangle. So we know that in geometry, P usually denotes the hypothesis and Q is our conclusion. And if we're going to write this down in if-then form or P then Q, we can write it in sentence form, and using our verbal statement, we can write it as if a figure is a square, then the figure is not a triangle. So from symbol form, we're able to write it down in verbal form because in mathematics, when we learn how to do things, we also need to learn how to undo things. And that's basically what we're doing here in this example. So what if we're going to write statements in if-then form, even though the statement is not looking like a conditional statement, similar to this one. So in our sentence, we have acute angles measures less than 90 degrees. And since this is obviously not a conditional statement, all we need to do is to identify our hypothesis and our conclusion to be able to write this down in if-then form. So our P here, we can say that our P in this solution, P then Q, can be an angle is acute. And our conclusion, it measures less than 90 degrees. And now that we have our P and Q, we can now write this in if-then form because we're able to identify the conclusion and the hypothesis from this statement. So if an angle is acute, then it measures less than 90 degrees. So notice that in any which form that we are presented with a conditional statement, we'll be able to understand it because we are now seeing that there's no one method or one way to write a conditional statement. Sometimes it's in verbal or sentence form, and sometimes it can be in symbol form. Now, in conditional statements, we need to understand that sometimes the conditional statement is true and sometimes the conditional statement is false. And how are we going to know if the conditional statement is true or false? We need to identify two things. One, a conditional statement is true if every time the hypothesis is true, then the conclusion is also true. So when the hypothesis is true, or every time the hypothesis is true and the conclusion is also true, then we have a truth statement. So what about a false statement? A conditional statement is false in this case if there is a counterexample in which the hypothesis is true but the conclusion is false. So you need to come up with a counterexample of your hypothesis that is true, but the conclusion is false. It can be a little bit confusing, but with an example, it's actually really simple. So let's try the first example here. We need to determine if this is a truth statement or a false statement. According to the statement, if an angle measures 92 degrees, then it is an obtuse angle. And since we know the language of mathematics, we know what obtuse angle mean, and we know that 92 degrees with this diagram is showing us a type of angle that is actually an obtuse angle. Now, can you think of a counterexample of your hypothesis that will make it true, but the conclusion is false? I don't think so. That's why this is an example of a truth statement, because all angles that measures 92 degrees can be considered or classified as obtuse angle. So this is a definite yes for a truth statement. So let's have another example, and let's say that in this example, if a month begins with the letter J, then the month has 31 days. So according to our rule, if you can come up with a counterexample that is true, but the conclusion is false, then this statement or conditional statement is false. And can you think of that counterexample that will make the conclusion false? I'll give you one, and that is the month June, because June starts with the letter J, which is a counterexample that makes the hypothesis true, but J or June has only 30 days. So that means the conclusion is now false. So that means this particular statement is also false. So this is how we use that rule to come up with or to consider a conditional statement is true or false. So remember, a conditional statement is false if there is a counterexamples in which the hypothesis is true, but the conclusion is false. And that's how we know that we are working with the truth statement or a false statement given these examples. So don't mind this example because it's just the same as the first one. So your number bender challenge for the day is for you to be able to write or compose a conditional statement that shows the hypothesis and its conclusion. And in this case, I want you to give me an example of a truth statement and a false statement that are also conditional statements. So that's going to be your number bender challenge of the day. So comment it down below and let's see how many examples you can think of. And that's our lesson on conditional statements in geometry. So again, it's not just important to know how to memorize formula, in geometry, we also need to learn how to think mathematically and to be able to understand the language of mathematics through notations and symbols can help us be more confident when we're solving with problems in geometry, specifically in conditional statements. This is Dr. E, and see you again next time. Bye!